I'm Al Sutherland with your Mesonet Weather Report. Dry line, dew point. Dew point, dry line. Maybe you're thinking if I wanted to know about dew point, I would have become a meteorologist. But even as a weather novice, we can use Mesonet dew point maps to gain insight into where storms might pop up. Turning to a dew point map from Monday at 2 p.m., we see a tight dry line across the state. A number of places had dew point temperature differences that went from the upper 30s to the low 60s within the width of a county. Camargo was 38 degrees, Watonga 61, Granfield 37, and Waurika 66. Higher dew point temperatures, the green-colored areas, show where there is higher moisture in the atmosphere. On radar, the first strong storms to pop up on the Oklahoma City radar were easy to see along the east side of the dry line at 2:10 p.m. The strongest cells were in Kansas. At 3:30 Monday afternoon, the dry line had moved farther east, and the distance between dry air and wet air masses was even closer in some cases, such as between Apache with a dew point of 38 degrees and Ninnekah at 67 degrees. Higher dew point differences over shorter distances indicate areas with more energy and lift in the atmosphere. Severe storm cells, like the strong ones that brought tragic fatalities, injuries, and damage to Oklahoma on Monday, formed along the wet side of the dry line. They formed in the areas with the higher dew point temperatures. On the Oklahoma City radar at 3:40 p.m., the storm that would produce an EF4 tornado was visible in western Garvin County. It formed where dew point temperatures were in the mid-60s. On this radar image, you also see a line of storms forming on the border of Oklahoma and Arkansas. These highlight that atmosphere moisture is only one ingredient of storm formation. A map from the National Weather Service's Norman Forecast Office shows the tornadoes that formed in south-central Oklahoma on Monday, May 9th. The red line was the EF4 in Garvin County. The orange tracks were EF3 tornadoes that set down in Murray and Johnston counties. A yellow line shows an EF2 tornado that formed in Bryan County. Green lines show the track of two EF1 tornadoes. All that was in the afternoon. In the morning on May 9th, we had a good example of how the Mesonet can be used to monitor rainfall intensity to be alert for possible flooding. At 7:13 in the morning, the Oklahoma City radar showed a large area of rain in south-central Oklahoma. A Mesonet rainfall map with rain amounts for the last hour at 7:25 in the morning showed that Ardmore had 1 1400 inches in an hour. Another way to look at the high rainfall rate is to check Mesonet meteogram graphs. On the graph for Ardmore Monday morning, the green fill area shows the rapid rise in the amount of rain. Fortunately, after this heavy burst, it slowed down and no flooding was reported. Thanks for joining us for this edition of the Mesonet Weather Report.